Good morning, everyone. Welcome to this session. A very warm greeting from Mercy Technologies. Welcome, everyone. So, what is the motivation of learning data structures, right? The motivation is how can you be a good coder if you don't know how good your code is? So, if we learn the way your code is getting organized inside the memory, which means you actually know what is happening internally. So when you know actually what is happening internally, then you have a better hand over the code that you are writing. When you have a better hand on the code that you're writing, which means you are an efficient coder. And most of the companies are looking for efficient coders. People claim themselves to be efficient, but they don't know how efficient their code is. So when you have a better approach or better hand on what you're writing, then you should be landing yourself in a very better position than your peers. So that is why this is required. I see many people who are having manager level experience, but they lack the knowledge on data structures and algorithms, and they themselves restrict by not moving forward in their career because of this restriction they have. So we need to overcome that, and the main motto of this course is to make you understand the data structures is not that hard. It's just a way of organizing your data in the memory and trying to learn what are the operations available in it and giving you a better hand on the approach that you're trying to use. Okay, so what is the agenda for today? I told you the agenda for today is there are two topics that we are trying to discuss, and the agenda is we are learning the memory areas, and we would be learning about the stack and how it is getting filled up due to the method calls, right? Let's move forward. Let me continue my presentation, right? So what are the method areas that are present? The method areas that are present, see, before I tell what are the method areas that are present, so what is the reason for learning all these method areas? See, for anything there should be a foundation, guys, and that foundation will decide either you move forward or you collapse, right? So even for learning data structures, there is a foundation, and that foundation will decide that you either are moving forward in a proper direction or sometime in your near future you're collapsing. So learning what are the memory areas that are present inside and how your code that you're writing is organized inside the memory will land you up in a better knowledge on what you're trying to write, and thus giving you a very good foundation for the future that you're trying to achieve, right? So let me explain what are the different memory areas. For that, let me go back and give you easy understanding. So what are the different areas inside? What are the different areas inside? Okay, the different areas inside are method area, heap area, stack area, the PC registers, and native method stack. So the things that are important to us is method area and heap area and stack area. These two are related to the operating system or the programming language specific. So let me tell you one thing, guys. This I'm dealing inside Java. So why Java? Java is a little bit more verbose and it is easier for you to understand. But this memory segmentation or the memory organization is almost similar. I mean, I'm not speaking about the PC registers or the native method stack, but generally when you go for any object oriented programming language, there is a place where you store the global variables, where you store the objects created, and where you store the stacks or the local variables, right? So the method area generally stores the global variables. Okay, it stores the global variables, and the stack area will store the local variables, and the heap area will store the objects that are created. So this is that simple. Let me not confuse you with any more knowledge on this. There are things to learn, like what is this LWA, what is OS, what is FT. I mean, maybe I'll be coming a little bit as I move forward in the session. Let me explain what these are to you. But important things to learn is method area, heap area, and the stack area. So heap area, what heap does, it stores the objects. What stack does, it stores the local data. And what method does, it stores the global data, right? It stores the global data. So let me be this is a good foundation. So what is method area? Method area is okay. So what is method area? It stores global variables. In Java, when we declare something as static, so it means it is a global variable. It means it is a global variable. And heap area in Java or in any object-oriented programming language, in heap area, objects are stored. Objects are stored. So objects are stored. So this is a very important area, because let's say we are trying to implement a linked list or a stack or a queue or whatever. So in any object oriented programming language, we are actually storing that data structure inside the heap, right? We are storing that data structure inside the heap. So this is a very important memory area for us when we are trying to learn data structures. So, and then there is one more thing. There is a local, there are local variables that get created. There are local stacks that get created, and that is there inside the stack area, inside this stack area, right? So when it is there inside the stack area, so what is actually happening? Let's say we try to run a small method which tries to print hello world. What happens internally? There is a thread which gets started, which is called as a main thread. And when the main thread gets started, the thread has a local frame, which is a stack frame. For every thread, there is a stack frame, right? For every thread, there is a stack frame. So what is there inside the stack frame, etc., we will learn today. We will dive deep into this today. Okay. So this stack area is required to store local data, right? So this is required to store local data. So let me be concise again, guys. Method area is storing global data or the static variables. Heap area is storing the objects, and the stack area is storing the local data. This PC registers a native method stack. I think, like, let me give an introduction. Native method stack is nothing but in Java, there are some libraries which use C language, which use some other language, and for that stacks it use native method stack. And PC register is like storing for the next pointer and all. Let me not go deep into these, but it's good to know. It's good to know, kind of, right? So method area, heap area, and stack area. With this knowledge, let me move forward. With this knowledge, let me move forward. So what is the thing? What are you trying to achieve over here? Now let's go hands-on. Let me explain you a simple example. I've created a new project. So close everything here. I'm using Eclipse today for you to explain a simple program and explaining you how different memory segments are used inside so that you can get a better grip. I'm trying to create a class, and I'm naming that class as employee. Okay, I'm naming that class as employee. Let me remove the unnecessary classes that I do not want as of now. So what I'm doing, I'm creating a main method, right? I'm creating a main method, and inside that, let me not create the main method, but what is the employee object? Let me define that first. So let's say the employee has nothing as of now. For our convenience, it just has employee ID and nothing else, absolutely nothing else. Okay, so what I'm trying to do over here is I'm trying to create one more class, which is a test class, and I'm writing a main method over here, right? when I try to write the main method over here, what I'm trying to do, I'm creating an employee object, right? I'm creating employee object E1 is equal to, okay, I'm trying to create an employee object. What happens because of this? Here, let me explain one thing, guys. This E1 is called as a reference variable, and the code that is there after the equal to symbol, this new operator is actually creating a new employee object. What I told, the employee object is created inside the heap area, right? Inside the heap area. So an employee object is created because of line number 5, right? Because of line number 5. Let me have one more employee object. I'm naming it as E2 equal to new. Okay. So what I have done till now is I have taken two objects. I have taken two objects. These two objects are getting created inside the heap, and this E1 and E2. What are these two? These two are reference variables. Let me explain that to you in a diagrammatic manner, right? In a diagrammatic way. Okay. So what have I done? I have created I have created two objects. I have created two objects. What is the first object name? The first object, the reference, as I told you, the local data is stored inside stack and the objects are stored inside heap, right? There are two employee objects that I created, and first employee object is this, second employee object is this. What I'm trying to do, I'm trying to have two reference variables, right? These two are reference variables. These two are local variables. As you see, there is this main method, and inside main method, I have taken two reference variables, and the memory for these two is allocated inside stack. And I have created two new objects, and the memory for these two objects is allocated inside heap, right? It's very simple. This is how the object allocation goes. Object allocation goes. Let me move forward a little bit and try to modify this code and say what exactly is happening internally. What I'm trying to do now, E1 dot employee ID equal to 10. What I'm trying to do, I'm trying to modify the data. I'm trying to modify of employee data. Then what happens? Actually, what I'm trying to do, I'm trying to modify the employee object. So the modification happens inside heap, right? So the employee ID now becomes 10, right? The modification is happening inside heap, and stack has nothing to do because stack is only holding the reference variable, right? So stack has nothing to do over here, but employee object is present inside heap, and we are trying to modify its value now because of the line code, because of the code 7, line number 7. What we are trying to do, we are trying to modify the value of the data inside heap. It is called as a behavior, it is called as a state of an object, guys. This I think maybe you better learn that in Java, but it's like, it's good to know that when you try to modify an object, some data, the state of the object is getting modified inside the heap. Now I'm trying to do one more thing over here. E2 equal to E1, right? When I say E2 is equal to E1, what exactly happens? Let me tell you what exactly happens, right? Let me copy that and paste it to you so that it will be easier for you to understand. So now what exactly is happening? This is what exactly happening. Now what we have done with the previous line, the employee object's value has become 10, and with the new code that we have written on line number 8, the E2 is pointing to E1, which means there is no modification inside the stack. Stack is as it is, but here we do not have this line now. We are pointing the E2 to E1, right? We are pointing to the E2 to E1. So what happens to this E2? Because nobody is calling, nobody is holding anything in it. So what happens? This one will get garbage collected. Garbage collected. Okay, so like Java has this mark and sweep garbage collection algorithm. Maybe it's not a good time to learn now, but the foundation what you got here is any local variable, they get stored up inside stack. Any objects that get created will be stored up inside the heap, right? People say that the screen is struck. Are you able to see? Are you able to follow me, guys? Could you please reply? Are you able to follow me? Okay, good, good, good. I get good replies. Please do rejoin the session, guys. I think maybe you can refresh your screen. Okay, okay, cool. By this foundation, what we are trying to achieve is we came to know that local variables are getting stored inside stack, and any objects that are getting created are stored inside heap, right? Right? Clear, everyone? Are you able to follow me till now? Are you clear with whatever I have taught till now? A simple program. Where is the local variable getting set, and where is the object that's creating? Small exercise what we have achieved is by this, like for example 4 to 10 lines of code. I think from 3 to 10 lines of code, what we have done, we have created two employee objects, we have taken two local variables, we try to modify something in the object, and we try to re-reference or make an object point to some other object. So we have done all these things, and internally how all this is happening. So we got a better picture by understanding what is going inside stack and what is going inside heap, and what happens when you modify the references, what exactly happens internally, right? This is, you will appreciate all this foundation, all this knowledge when we start solving the problems in the data structures like linked list, stacks, queues, and trees, and graphs, right? You will appreciate this concept. I mean, this is not rocket science. This is very simple. This is very simple. We have written a small program over here and try to understand what exactly goes inside stack, what exactly goes inside heap, and what happens when you try to modify the references, what exactly happens, and if there is no reference, and there'll be a garbage collection which happens internally. It's a daemon thread which runs inside Java, inside JVM, and then it collects all the non-referenced variable or non-referenced objects inside the heap by a term which is called as a garbage collection, right? Which is called as garbage collection. So what we have achieved now. So let me go back and open the same thing again, right? Same thing again, so that you can understand that better. Okay, so right, what we have done now. So there is a method area. Method area, it stores all the global variables. I have not told anything about the global variable as of now, but I'll tell you now. So this heap area, it stores the objects, and then the stack area, which stores the local data for every method call that happens. We have a new frame inside the stack which is called as an activation frame, which we are going to see right now. At the same time, what happens for every thread that gets created, so there will be a separate stack, right? There will be a separate stack. In our case, in our program, so what we have done, we have a method which is called as a main method, and main method is being called by main thread, and main thread is having a stack frame. That stack frame has all this local data. I'll tell you diagrammatically what or how that happens. Okay, so I told you that there is method area, and we have something called static data. What I've done, static. For example, let's say we are trying to create an object for a particular company. Okay, for a particular company, so every object has some global data, like every employee may have a different employee ID, but the company name would be the same, right? String. What I'm trying to do, okay, so here what happens, I have created something which is called as a static variable, and the static content is something called a company, right? You can initialize that value, that initialization part, that's all a different story. But when you have something which is static, this static content goes inside the method area. It goes inside the method area. So simple thing, guys, simple thing. What happens when you try to write something, the objects get stored inside heap, the static content goes and gets stored inside method area, and the local variables get inside the stack. So let me write one more small program so that you can understand that even in a better way. I'm trying to explain you what is the stack and how exactly it is getting stored inside. So what I'm trying to do, I'm trying to do some, I'm trying to write a new class which is called as a method call example. Here we are trying to do the thing. Okay, okay. So what I'm trying to do, I have tried. Just a second, guys. So what I'm trying to do over here, I'm creating a method one, right? Method one. So this, okay, this we cannot do it. First, I'm trying to create a main method, and inside main method, I'm trying to call a method called m1, right? I'm trying to call a method called m1. M1 is not present, control 1. I'm trying to create a method called m1. So inside m1, what I'm trying to do, I'm trying to have local variable int a, right? So inside method m1, I'm trying to have a local variable called a, and inside m1, what I'm trying to do, I'm trying to call a method called m2. So I do not have m2 over here. I'm trying to create one more method, which is m2, right? So inside m2, what I have, I do not have anything. I just have int b. This is the local variable, and I'm trying to call methods called m3, okay, and m4, right? I do not have methods m3 and m4. I'm trying to create them now. I'm trying to create them. Okay, so this m3 has nothing. It just has int c, right? So we have one more method which is nothing but m4. I'm trying to create one more method which is m4, okay. I'm trying to have int d, right? Int d. So what I have done now, I just created a main method, and inside main method I called a method called m1, and inside m1 I try to call a method called m2, okay, and after that I try to call a method called m4, right? This is simple code, very simple concise code, guys. So let me explain what exactly happens inside internally, so that it will be very easy for you to understand. Let me be very clear on all this. Okay, so what I'm trying to do, let me try to explain you in this way. So I'm putting this in the notepad, in the whiteboard. Okay, what have we done now here? The thing that we have done is we have written a simple code which has a main method, and after that it's trying to call different methods in it. Let me do. So what happens, I told you, whenever we have a method, it is internally creating a activation record. Here, let me try to explain. We said that a stack gets called internally, right? A stack gets created internally. What is the stack doing, guys? The stack is nothing but this stack is responsible. A main method is being called, and because of that, for a main method, a new thread is created, and that thread is initially loading a method called main. Okay, it is loading a method called main. Okay, it's it's loading a method called main, and after main method is loaded, it is internally calling what? It is internally called m1. Okay, this m1 method, what it has a local variable called a. Okay, this local variable is also stored inside the stack. You need to understand this. This is a stack. This is a stack. Okay, this is a stack. Okay, so inside stack, a main method is loaded, and after that, a method called m1 is loaded. M1 has a local variable which is a, and then what is the next step that m1 is doing? It is calling m2. So what happens? M2 gets loaded. M2 gets loaded into the stack. What M2 has? M2 has a local variable which is called as b, right? M2 has a local variable which is called as b. So again, what M2 is doing? It is trying to call M3 and M4. So what is it trying to call? It is trying to call M3. Okay, so M3. So what is M3 having? M3 having a local variable C. This this is the local variable C, and after that M3, it is done with this execution. It has nothing to do. So what happens? This activation record gets destroyed, right? This activation record gets destroyed. This activation record gets destroyed because M3 has nothing more to do. After that, the control comes back, and what M2 is doing now, it is trying to call M4, right? It is trying to call M4. So this is a stack, guys. The insertion happens at the top, right? At the top. This is a stack, and the insertion happens at the top. No, so now we have an empty space at the M3. So we are calling M4 over here. Okay, we are calling M4 over here, and M4, what it has a local variable called D, right? It has a local variable called D. Okay, now we are done with this D as well. So let's try to, what is M4 doing? M4 is doing nothing. Now we are destroying this as well, right? After this is done, after M4 is done, the M2's execution is done. So we are trying to discard M2 as well, and after M2 is done, the control comes back to M1, and in M1, what it's trying to do, it's doing nothing. After the call with M2, it's nothing. So M1's part is also done. Now the control comes back to this main method, and what it does, even the M1 its execution is done. Finally it came, main method has nothing to do, it doesn't have any SOP statements, or it has nothing to do now. So even the main method is discarded. What happens here? The thing that you need to understand is, guys, there is a stack that got created for this small example, and inside stack, for every method called, there is a box which is getting created, and this is called as an activation record. Activation record. So there is something called an activation record, and this activation record, what it has the local variable data as well. In this case, it has the value of A, B, C, and D, which is specific to that particular activation record. And after the method call is done, all the local variables and everything gets destroyed internally, right? Gets destroyed internally. So after the whole method stack's execution is done, the whole stack is destroyed internally. That happens internally, guys. So this is what you take any example or any code, any number of lines, say 1000, 2000, whatever. So what happens internally? For every method call, a stack gets created internally. All the local variables are stored inside the activation records, and once the execution of that particular method is done, the activation record gets destroyed. So which means all the local data that you have gets destroyed. So that's why we say the local data or the local variable inside of a method, we cannot use it outside. The reason, after the execution of that method, the activation record gets destroyed and we do not have that data available anymore in the memory, right? This is what it is. So with this, guys, we have a good foundation on how the memory is organized. Whenever a method is called or whenever a small program is called, how a stack gets created, how the method calls happen, and like how it is trying to reuse this space. So here what happens, so here M3 is done. So what happens now? This area is free. So this is called as a top of a stack. Top of stack. So whenever top is free, so what happens again? This area is free. That is why the insertion again now happened at top, right? We are reusing the space. This is how it exactly happens inside the memory, guys. So what happened? We have done two things till now in our session. So first thing that we have done is we exactly understood what is stored inside the stack, what is stored inside this heap, and by again taking a small example, we were able to understand what is the stack that is getting created internally, why local variables are not being used, available or not available throughout the program. So this is the foundation, guys. This is a good to go foundation. Let me tell you, this is a very good to go foundation. If you're clear with these concepts, then believe me, you are going to rock in learning data structures and algorithms. Let me finally tell you what are the things that we have learned till now in this session, right? Just give me a second. Just give me a second. Okay. Cool, guys. So what have we learned today? We need to learn the memory areas and how exactly the data structures are stored inside memory. The reason is, when you have a good grip on how the data is stored inside the memory, you would be in a position to analyze that by just seeing the code. And since we are trying to write data structure is nothing but a structural way of storing something inside your memory. So you need to learn. So that's what our point one is saying. And second, objects are stored inside heap. Every thread has its own stack. Method calls are stored inside the stack memory. Okay, these three are very important things. And every method call has an activation record inside the stack. That's what we have seen over here. All these boxes are called as an activation records. So every method call has an activation record. Okay, activation records get destroyed after method call completes, and stack gets destroyed after the whole method, the main method or the calling method gets destroyed, right? This is